So, hello together to our lecture in statistics and what we will do today after we went through a little revision. Let's do this again, where I just hope that you have remembered something about statistics. So what is a random variable? What do we want to explain with random variables? So, for example, rolling the dice and calculating, for example, the probability that the dice shows a number smaller than 5. Of course, this would be 2/3. And then we have the distinction between discrete and continuous variables. And we, of course, then interested in probabilities and expected value and variance, and these were the difference between a discrete variable and a continuous variable. That, of course, we have to go from summation to integration when we move from discrete values to continuous values. Well, in this lecture, we will mostly do something with discrete data, especially when we use something like time series analysis. What we will do later on in this lecture, doing multiple regression. And I hope that you just remember how to calculate an expected value, just the numbers from your sample times the probability in the discrete case, or the quadratic deviation times the probability. This is then called the variance. Okay, here, this we will need in a minute when we are doing exercises, is how do we calculate with variances and expected value. So the first is that expected value is just linear operator, and in case of variance, of course, if we move all our data to the right, maybe +3, then of course the deviation around the expected value doesn't change, and we have the quadratic deviations, so the constant value gets out with a square and the b is vanishing. Okay, then we have our random sample, and then we want to describe this random sample, and there we have some different aggregate variables. The first variables are more or less some kind of means. There I introduced, hopefully from your introductory courses, median, arithmetic mean, geometric mean, and harmonic mean. This we will also do, that we calculate these means in an exercise. Range, very easy. We put just the two extremes to the left and to the right, and this would be, of course, the range of our random sample. And then aggregate variables describing the spread of our random samples, mean absolute deviation, or of course then the sample variance. And here we are the formulas, and these we will just take in a minute. I think this I have to change here to the right one. Oops. And as the arithmetic mean, there we will show some nice properties of the arithmetic mean. Geometric mean, just the nth root from the product of all our data. And the harmonic mean, is, I think I wrote it the last time, that this, if we write it in another way, then you can write more or less n to -1 times 1 over x1 plus 1 over x2 plus and so on 1 over xn equals n to minus 1 x to minus x1 to minus 1 x2 to minus 1 plus and so on. And therefore we see this is more or less the same as the arithmetic mean, which was this was 1 over, and this also to minus 1. So 1 over n x1 x2 plus xn. So in this case, in the harmonic mean, we just introduce this exponent of minus 1 and everything else is the same. And where we have to use the different means, this we will do also in an exercise. Then mean, absolute deviation, variance. There we will also talk about why we have these different factor here in front. This is then called the so-called sample variance, and why do we use in generally we don't use by just dividing 1 over n, but we have to divide by 1 over n minus 1. This we will show also in an exercise. Standard deviation, corrected standard deviation. And then, the third and fourth moments, and I think these are two new variables, and these new variables they are also in order to describe our sample variance, that, for example, we have a right skewed or a left skewed f of x, f of x sample distribution. And this is quite often also interesting, not only knowing the spread, but also if our main part of the mass of our samples is more on the right or more on the left. And for this we will also have an exercise. Okay, done. We will start with our exercises, and hopefully you have had a look at it, that we can do this together. And I will do this. I showed you in the Moodle room that we will do this mainly with Excel. So all of you are sitting in front of your computers, laptops, or anything else. So at first we have a class with 17 students. So today we are 5 students. Down. And we are measuring from every student the height. So first is very tiny student, 158 centimeters, second 177 centimeters, and so on, up to number 17. Class B will have 12 students, and at first we should calculate the arithmetic mean from class A and class B. I think this is not very hard to do. So let's open Excel, and I move this here, and also that you can see the menu. So first of all, we need to get the data inside of Excel, and this I show you also. Then you can just copy these numbers. And this is quite often that you have data just in a PDF file, and therefore you also should know how to do it efficiently to get your data inside your software tool. And so then question, take also the second class. Second was h, our random variable. So how would you calculate the arithmetic mean in Excel, or what you have to do? Please give me a feedback. Maybe you can also open your audio system. Yes. Yes, of course. This is absolutely right, just the definition and of the arithmetic mean. And this you can do in Excel, that you just type in here. Well, this is still the German version. I also gave you, if you want to do it all in English, the Excel translator. Oops, not suchen, but sum up. And we just put all the numbers inside here and enter. This is 3005, and then we divide this one by 17, of course, and this would be then the arithmetic mean. So that's x bar as the arithmetic mean. But of course we have our software package, and then we can also use just the mean. Oops. No, we need the mean. And if you take this one, we also put all the numbers inside and enter, and hopefully this will be the same, of course. So in the case of h, we are doing the same. Summation. And this one divided by 12. Or of course, just the mean. Of these numbers, and the average age would be 18. So of course, very simple. So what else should we do? Take class A and calculate the range, the mean absolute deviation, the biased and the unbiased variance. So for this we need just our formulas. This was the mean absolute variance, not the variance, mean absolute deviation. This and biased and unbiased variance. This one. So exercises there. Oh, sorry. As I saw here, the median we should calculate at first for class A and B. What do we have to do if we want to calculate the median of these two random samples, class A and class B? What do we have to do? So these are our heights. How do we calculate right now the median of these two random samples? So the mean is just something like the middle of our distribution. But now how do we obtain the mean? And sometimes, well, if you take some data, let's say for your bachelor thesis or something else, then you have a distribution, and then it would be interesting if you know the mean and the arithmetic mean, the median and the arithmetic mean. So what should we do? Let's move this one here a bit away. Because we need some more cells. Any idea? Well, we can do it, of course, by hand, and then we look it up. I think here 156 centimeters is the smallest person, then 158, and so on. But this will take some time. So what we can do is, of course, take the data, and then we manipulate the data, and oh, this you don't see here, so I move it down. And this case, so, but now you don't see the whole data. Again, so let's take, I think 90% would be enough. Yep. So then you go to data, and then we want to sort it. Then we take the height and from the smallest to the largest person. And there we have it. So now we have the data in a row. And how do we obtain now the median? Still we have 17 people in class. I know it's quite early this morning, but what is the middle of this distribution? You have 17 people. So then, of course, if we go to, yeah, some idea? Ah, we just, or did I write it wrong in the lecture? Let me see. Hopefully not. Oops. So here we are in the formula and we have odd. And if we have an odd number, then of course we have a middle. So we do not need, or you mean this formula? Okay. So in this case, we have just the middle, and then of course you can do it. So if you take these, so to speak, abstract formula, and we want to calculate in this case the mean, the median. So then n is 17 plus 1 is 18. So in this case, so, or am I wrong? So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have below 9 people. Then it should be here the number 9, that this would be the median. Or let's make this, because this is then the middle of our distribution. And of course, we have also the function median. And let's see what happens. We have also our 178, because this is just the middle of the distribution. And if we go to class B, then of course we don't have a middle in our distribution as a pure number, but let's at first sort this numbers also in a row. So we go in here and data, sort H, and in this case we have to take n divided by 2 plus n divided by 2 plus 1, these two numbers, This would be then if we have 12s, numbers 6 and 7. So 27 and 28. And since we have no true middle, here for the median, we take the arithmetic mean of these two numbers. So 0.5 times 27 plus, I need here is 27.5. And of course, we can do this also with a direct formula. And then we also obtain 27.5. Okay, but then we want to go to mean absolute deviation and variance and so on. So let's take a new sheet, 11B. This was A11A. We take the data from here. This we don't need, and this also not. Yeah. Let's take it like this. Smaller maybe. So, first was, I think, range, and yeah, then we start with the range. So, how do we obtain the range of these two random samples? This is all introduction to statistics, what we are doing right now. Hopefully. So then just a question. Mean absolute deviation, variance, range, something like this you should have heard already. But anyhow, I gave you just the definition. So how do we obtain the range of class A of the heights of the students? What do we have to do? Yeah, well, yes, of course. And yes, no, and well, it's not that much here, so we know that 156 and have a look, I think 199. These are the numbers, but of course we want to do it, and if you have 100 numbers or something like this, then it is not that easy just to have a look on your sample. So you have the formula minimum of our numbers, and we have the formula maximum of our numbers. And then of course we have this minus this one is 43 centimeters, and here we are doing the same. and this one minus this one. So we have the range. Let's move this down here. Well, of course, you get the Excel files afterwards also via your Moodle course or on the web page, I think. Let's take this a bit smaller. So, and now we want to go to medium absolute deviation. What do we have to do? Well, we just go into our formula. And what was medium absolute deviation? We take the absolute deviation of every number with respect to our, is it working? Yeah. Oh, this is the wrong one. So this one. So with respect to our arithmetic mean. So at first, of course, we need again our arithmetic mean. Up. And then we absolute deviation. So there we have also a formula called ABS. And then we take this one minus our arithmetic mean. And since we do not want always to type this formula in every cell, therefore we have to fix these arithmetic mean down here, the cell B20, and the cell B20 is fixed if we put just the dollar before the B and the 20, because then we can move down our formula. So if we now start to copy this one, putting this down, we have all our absolute deviations for the single numbers. And what do we have to do now? Let's go back. This is our formula. So statistics is always about manipulating data, and this you should learn, or it would be quite good if you can do this. And if you are working later on in some company and you should do some simple descriptive statistics, then sometimes you don't have any statistic software package, but quite often you have an Office package. So these are all the absolute deviations of 158 minus 178, 76.8, and so on and so on. So what do we have to do now with these numbers in order to obtain the mean absolute deviation? Well, I hope that you see this. Well, what we have calculated now is just mean absolute deviation of every single number. So this is just a new single number. And what we have then here is just sum it up and divide it by n. So nothing else than the arithmetic mean of the absolute deviations of every single number. So in this case, we can just take our formula and put this formula to the left. So this one would be the mean absolute deviation. And this, of course, we do also with our second class. So we have again our arithmetic mean. No. Oh, there's an M. That was wrong. Then we want to have the absolute deviation. So abs of this number minus this number, and test 1, 2, 3, 4, 5. Yeah, because it's working here. You hear me again? Okay, good. So again, to recapitulate this, we take the arithmetic mean here, we calculate all the absolute distances, and then we take the arithmetic mean of the absolute distances. Okay, then how to calculate I think the variance, corrected and uncorrected variances. We should biased and unbiased variance. Well, I think in this case we could go a bit faster. Let's go again, go to the formula. There it is. So in this case, we just have to calculate the mean absolute quadratic deviation. Therefore, we have again our arithmetic mean here. I think this has to go one down. So let's write this xi minus x bar squared, that we know what we are doing. So in this case, equals to xi minus arithmetic mean, fixing with two dollar signs, closing brackets up to the square and going down here. And after this, we see just divide this by n, Oop. So we have again to calculate the arithmetic mean of these numbers. So this would be the unbiased. Let's move this here one up to this part. So this would be the unbiased variance. And how do we obtain biased variance? Well, in this case, we have to divide the sum of these numbers just by n minus 1. So, for example, we can do this, sum it up, dividing by n is 17 minus 1. So this should be a little bit larger than our 134. Oh, sorry, this is a biased variance, and this is unbiased. Unbiased. Why it is called unbiased? Well, 10 after 9. We see if we can do this today. So here we also want to do the same. So in this case, and this you should also try, we have here our formula. Therefore, I just copy this formula in here, and then we look what we are doing. Already clicking in here, the 19 is right, but we have fixed this cell here, and we want to take here the arithmetic mean, so we need this number there. And this is 18J18, so just change this number here, say 18, going down here, and taking the mean, up. So where is my mouse? It's here. Closing brackets and equal sum divided by 12 minus 1. Should be a bit larger also. Okay. This is the unbiased variance and the biased variance. And this was the mean absolute deviation. So, and then a very hard task, we should also calculate the uncorrected and corrected standard deviation. Well, and this was just defined by, where do we have it? The square root of the biased and unbiased standard, biased and unbiased variance. So just taking the root of these two numbers, this one and this one. So this is the uncorrected standard deviation, and this is the corrected standard deviation. And this, if we have done this here, we can just copy this up to here, because all our formulas are just moving to, oops, this part. Let's change this to and now you see the numbers here. Because if we click in here, this is just the root of L15, so it's the root of 42. Okay, I think this was 1b, and then we go to other means, and number 2, in the last 4 years, a stock market investment had the following performance. So our stock has risen 10%, second year was quite bad, minus 15%, then 12% and plus 7%. Or we have a saving contract where we obtain every year the same percentage, and this investment evolved from 1,200 euros to up to 1,350 euros. And so if we look to the performance of the two investments in the past, we just want to compare these two investments. Which one of these investments had the better performance? And we want to calculate the average yield per annum, so per year of these two investments. How do we do this? 10 minus 15, 12, and 7. So then let's go to number 2. A2. So again, we have plus 10, minus 15, 12, and 7. 10 minus 15, 12, and 7. 12 and 7. And this is all in percent. This is investment 1 and investment 2. Had a performance of, let's move this one down. What did we had? 1,200 and 1,250. So which investment is better? We want to decide this by calculating the average yield per year. This you should have seen, of course, in your introductory courses in statistics, but maybe also in mathematics, and if you had also a module like investment decisions. So how do we do this? Actually, we had also done this in my macro courses. It's always the same. So in this case, we want to calculate the constant interest rate. So in order that we come in 4 years from 1,200 to 1,350. So then let's go Here, what is the task? We have investment in time 0 is 1,200. And then after here, E1, E2, E3, I4. Here we are at 1,350. So the question is, 1,350 is equal to 1,200, 200 plus 1 times 1 plus our interest rate R. And we go 1, 2, 3, 4 times up to the 4. So what we have to do is taking 1,350 over 1,200 up to 1 over 4 minus 1 equals R. Hopefully this you have already seen. So in this case, yield per annum equals to 1,350 over 1,200, 200 up to 1 over 4 minus 1. Let's take this in percent with, let's say, 3 digits. So, what is the performance of this? Can we just take here our number calculating the arithmetic mean? In this case, we would have is mean of this would be 3.5. Is this how we have to do it? So this one is better than this one. What do you think? Well, let's take also an investment of 1,200. And in this case, 10% up in the first year would be 1,200 times 1 plus 10%. So we have to divide this by 100 and going down. Then we have these 1,320 going down by 15%. So the same formula, but we are going down. Then up with 12% and up with 7%. And voila, we see we coming to 1,344 is less than 1,350. So taking just the average via the arithmetic mean is of course wrong. How do we obtain now the average yield of our stock investment? Well, this is just an example. Here we have a growth process And if you have growth processes, you always have to use not the arithmetic mean, but the geometric mean. Well, we can calculate it if we have these numbers now in the same way as these numbers. So again, we take this divided by this up to 1/4 minus 1. And then we see here we have a yield a bit less, 2.89 compared to 2.98. But we can also, of course, do it directly. In this case, we just calculate in here the so-called interest factors. So this 1 plus 10/100. So these are the growth factors of every year. And in this case, we take the geometric mean of these numbers. So not this one, only this one. And then we have to subtract 1 minus 1. And this is the same as this. So again, percent and up and here. And let's go down here. So this is the geometric mean of our growth factors. Subtracted by 1, we obtain the medium yield of our stock investment here. Okay, all this should be just a revision what you have already seen. Then let's go to number 3. Consider two firms, A and B, issuing no new capital in the medium term with the following market capitalizations PI and the net income EI over EI. And we have capitalization of 200 billion euros from A with a net income of 8 billion. So this would be a really large firm, 200 billion euros. And in the other case, we have a smaller firm with market capitalization of 800 million euros and net income of 4 million euros. And now also, if you are an investor and you want to make some kind of a portfolio investment into firms A and B, then you can ask some kind, what is the medium price earnings ratio of these two firms? So we want to calculate something like an index out of these two firms, and this index should be constructed by 50% investment in firm A and 50% of investment in firm B. So let's calculate this also. Exercise 3. Which kind of numbers do we have? We have 200 billion and 8 billion. So firm A, 200, and since the other smaller firm, there the unit is million, we put these numbers also in million in order to compare these two firms. So, and we have 8 billion here. So 8 and firm B would be 804. 804. This was market capitalization and this net income. So what we want to calculate is price earning. So P over I E equals this one divided by this one and this one divided by this one. So also if we think of it in order to get the average at first, yeah, the first guess is always just again calculating x bar, and this would be then 0.5 times, oops, we have an equal sign here, times this plus 200. And do you think that if you take as an investor an index of these two firms, a very large and a very small firm, that on average you would have a price earning ratio of 112.5? Of course, this could not be right. And cause why this could not be right? Well, we have here a very small firm with a very high price earnings ratio of 200 and this very large firm. But of course, if we just take the arithmetic mean of these two price earnings ratios, then we do not consider that we have here a very large firm and here a very small firm. And therefore, in order to obtain really the right price earnings ratio, in this case, we have to calculate the harmonic mean. So again, this is wrong, and we have to calculate the harmonic mean. So how do we obtain the harmonic mean? Let's go into our formulas here. So we have to calculate the inverse, sum up the inverse, then again take the inverse and multiply it by the number. Of course, the number is now 2 in our case. So we take 1 over 25, these two, and the harmonic mean is then 2 over the sum of two numbers. And in this case, we obtain the right answer. And of course, the price earnings ratio, since this firm here is much larger than this firm, should be closer to the price earnings ratio of the larger firm. Okay, then let's see what else. After this, we would come to some abstract properties of our arithmetic mean, but since we running out of time, I think we do this then on Monday. Well, if not everybody can enter class on Monday, of course I will record these solutions of these exercises too. But hopefully over the weekend, maybe you have a look into the exercise, because it should not be only the task of the lecturer in doing exercises that I give you just the solutions. Okay, then I stop the recording.